All right. Good morning. My name is Jeff Martin. I'm one of the software developers that works on nextPYP. This morning, I'm going to talk to you about the overall architecture of our software, how to install it, what the user interface looks like, and a few other goodies too. Just to give a brief outline of what I'm going to talk about, among the software architecture section, I'm going to talk about different options we have for deploying our software and what kind of hardware environments where it makes sense to do that. And so I'll answer some of the questions in my talk that were raised in the previous session about what kind of hardware requirements you need to have to run our software. I'm also going to talk about the user interface, how to find features within the software and its interface. I'm going to talk briefly about not necessarily how to install our software, just because that can get very detailed and we only have time to do a high-level overview here. But I'm talking about what are the options you have during installation and how to find instructions for going through that process, and also configuring our software a little bit after the fact. We'll talk about some maintenance and administration issues like upgrading our software, managing the options within the software, troubleshooting issues if they arise. At the end, I'll talk briefly about some programmatic interfaces that we're developing, so you can use your Python app to integrate with our app if you so choose. And at the very end, I'll talk about when you run into problems, how do you get help from us and other people on the PYP team. Okay, system architecture. At a very high level, what our software looks like is a collection of components that interact with each other. And the simplest version of this, we're going to talk about a local standalone deployment. So if the hardware you have looks like this image on the left here, maybe you've got a desktop computer with a monitor and a keyboard plugged into it, you're going to want to start with this kind of deployment, where basically everything runs on one computer. So nextPYP is made up of two components. One is called Next and one is called PYP. The next component is the website, the main interface that you'll be interacting with. And it talks to the PYP component, which does all of our backend processing and data analysis. And they talk over a mechanism where the website launches a process that does the data analysis, and then that process will talk back to the website using web protocols, HTTP. They'll share a file system, where we talked about where you need to store all of your huge amounts of data. And then the website has a database where it stores a lot of metadata in a way that is easy to access, often much faster than querying metadata from a file system. And then in this case, you'll have your web browser just on that computer, with your monitor and keyboard, and you'll interact with everything locally. From here, we can add on options to make your installation more powerful or make it easier to use in some way. So one of the options is you can add on remote access. So if your compute hardware looks like this, maybe you've got a server in a server room somewhere, you can access it from your laptop. And the way that works is it's just using web technologies to connect over the internet or possibly over a local network. Okay, so for this type of deployment, we can talk a little bit about the hardware requirements. They're pretty steep since we do all the data processing on this one machine. So we're looking at basically as many CPU cores as you have, at least two, probably, hopefully a lot more. And then per core, you're going to want about 4 GB of RAM. You're going to want local storage, large, fast local storage, probably SSDs are what you're going to want in this case. Almost 100 GB per core. Since jobs can be run in parallel, you're going to need to have the storage space for all those jobs at the same time. With this kind of setup, we'll say the kind of data processing you can do is very small to small. So in more quantitative terms, that would be tens of tilt series or low tens of thousands of particles. If you want more processing power than that, if you want to work on larger data sets, you're going to need more computing hardware. So if your computing hardware looks more like this picture on the left here, this is a data center, a few racks in a data center. We can support deploying on Slurm clusters. So the way it works is we'll call this a cluster deployment. This box here represents, one machine that's running our web server. And then we move all of our actual compute into the Slurm cluster. And the way that works is the next website software will SSH into the login node of the Slurm cluster. It'll call Slurm job submission commands, and it'll run PYP jobs on the nodes of the compute cluster. And then the mechanisms for talking to the website are slightly different. They'll share a file system. It'll be a network file system, and that'll typically give you access to lots of storage, although it can be a little slow sometimes. And then the website will use its web protocol channel to talk to the website to send data back, which the data website will store in the database. And then there's one last option. If your data center maybe looks something like this, maybe you're in a very secure facility, you might need to run everything inside this Limb cluster, and we support that option as well. For this type of hardware setup, you're going to need one computer to run the web server. This is our Next software. And then you're going to need the full Slim cluster, the login node to help you to log into it from the web server of SSH. The compute nodes in the Slim cluster should be spec'd about the same as the requirements they gave you for the single standalone computer, but hopefully in a cluster you just have a lot more of them. And you'll need that network file system. And for this, basically, depending on how large your cluster is, you could scale to any data size. The software will scale with you. Practically, we're talking about thousands of tilt series on the upper end and maybe hundreds of thousands of particles. Okay, so that's it for the overall architecture itself. I'm going to talk a little bit about a user interface now and how that is organized and how to find the things you're looking for within it. So the high-level organization of our software is into two main areas. One of them is called projects, and this is the area we're going to process or reprocess existing data. And then within that, you saw some screenshots of this earlier in the previous section. Each data processing task inside a project is going to be represented as a block on your screen, and you can chain them all together into data processing pipelines. The other side of this is what we call sessions. This is our data processing during acquisition or on the fly, and this gives you pretty close to real-time feedback about your data collection and the quality of data that you're getting, and hopefully that can be used to inform your data collection process as it continues. So here's a look at our projects. So the main screen in our software is this project dashboard. It shows you all the projects that you have running. The screenshot you're seeing here is some test data from my testing instance here. And this is just one-stop shop for all of the projects. I've highlighted one in orange here. If we go into that project, we see this block interface again. This is our project view. This is where you're going to be spending a lot of your time designing your data processing workflows. So over here, we have a block. And each block, as I said, is like one data processing task. This block on the far left is our data import block. So this is what allows you to bring data into your project. And you'll notice it has a whole area over here called movies. That means this block produces an output called movies. And then you can connect that to any block who has a little connector whose input is called movies. And so you can build chains of these blocks together where the raw data produces movies. This is a single particle data flow. And then we can pass it into the pre-processing block, and that will in turn produce particles, and then you can go on down the chain, you can refine particles. And that's represented in this view with these connectors. Over here on the right, you have a run button. So once you've put all these blocks in your user interface, you can configure them using menus and set options and performance settings. And then you hit run, and our software will take all those data processing tasks and line them up in a big list and just go through them one by one in order. And you can see the results of that over here on the right, where you can see I've done some previous runs in the past here. The most recent run, I did a particle refinement. So that's this block here. I just ran it by itself, but you can run all the blocks and it'll run sequentially. And each block will have subjobs in it, and you can see the results of these subjobs as they're happening. I won't go too much into detail here because you'll hear more about that later in the talk, but the overview here is that each subjob that launches within one of your blocks has progress information about how much work is done, how much work is left to do, and then at the end you can get information. You can look at the logs and see if any errors happened and get feedback. One more thing to say about this is each block inside of it has its own little world, and that's where you look at the results of these jobs. And so if we were to go into the pre-processing block, we'd see a lot of the figures that you saw in the previous session of our workshop, where you get to see the actual results and data output from the data processing. One really cool thing about this connection topology is that you can make branches in your graph. So here, I'm showing the same graph I had before, but now I have this new block over here. And what this allows us to do is so we did this particle refinement before, we got a lot of results, and we're happy with those results, but we kind of want to ask what if? Well, what if we changed a processing parameter and maybe we could get better results? So you can do that by creating a second block that's connected to the first one and run with different settings. And then you can have both data sets at the same time, and you can compare and look and see which one you like better. Maybe keep one, maybe get rid of the other one, maybe keep both. It's sort of up to you. But our tool gives you the ability to try things out without losing any of your previous work. Another feature of our software is that projects can be shared with other people. If you have, I'll talk about multi-user mode a little bit later, but if you have a system that is configured to have multiple users, by default, people don't see each other's projects, but if you want, you can take your project and share it with another person using this interface. In this example here on the screen, I'm showing that I've shared this project with a user called tester on my testing system. So that's it for projects at a very high level. I'll talk briefly about sessions. Sessions is our on-the-fly data processing system during acquisition. Here's the interface for that. You can see I have a few testing systems, both testing sessions on my system, both single product line and tomography. Each row here represents a session. You can give it a name. It has some statistics about data collection. Obviously, these are very small for testing. And there are some buttons over here that allow you to interact with the session. One of these will take you into a whole other interface for the session that you'll hear more about later during the workshop. One important point to make here, though, is that the way we've structured our data access rules are that sessions are owned by groups, and a group might be a research lab in an academic organization or something similar in other organizations, where the group that collects the data, everyone who's a member of that group can have access to reading it and processing with that data. Okay, so now I'll talk a little bit about how you get the software and how you get it running. We'll start with the basic version of this, which is the local standalone deployment. And again, I don't have time to go into a lot of detail here, just for length. But what I can do is point you to where our documentation is, and our documentation, I think, is pretty good. So it'll walk you through all the steps you need to do and help you with troubleshooting and things along the way. If you go to our website, nextPYP.app, there's a big old button there that says go to the latest documentation, latest version. That'll take you to a page that looks like this. There's a big blue button that says installation. That'll take you to a document over here. And this will walk you through everything you need to do to install the software in our basic version. And we've tried very hard to make this as simple as possible. So to give you an idea of sort of the flavor of what this installation procedure is like, because, who knows how long this document could be, right? I've cut it off pretty early on. But what the basic install instructions kind of boil down to is you install a few prerequisite packages from your operating system, you download an installation script, you run it with a couple of arguments that describe your environment. That's going to do a whole lot of work for you, downloading software, setting up configuration. It's going to leave you with a configuration file that you can then edit to customize the installation for your environment. And then optionally, there are things that you can add on past the basic version of our software to do other things. Also point out that this normally needs root access to do all the fancy things. You can run it in a non-root mode if you need to. Some of the things work a little bit differently, and our documentation on this isn't quite there yet, but we're working on that in the near future. So after the installation is done, you can end up with a whole bunch of installed software, ways to start and stop it, and then this configuration file. This configuration file is going to be a tool for administrators to customize how the software works in their environment. By default, it's in a location in your file system. The installation instructions will point to all of that. We chose to use a standardized format for installation for our configuration file. It's called Tom's Obvious Minimal Language. This just means that the file format has well-defined rules and semantics that you can look up online and then learn more about that if you want. But what it means is that your configuration is fairly self-explanatory, right? So there's sections here, there are values that there are variables you can assign values to. The values can be strings or arrays and so forth. And when you need to make changes to this file, the instructions will help guide you through that process and what values to choose. There are a lot of options that are available here. I'm showing a small selection of them on this slide, but we have in our documentation a full reference of every possible option, why you would want to use it, what values it accepts. In this section of our documentation, down here, if you go to the menu part of it, you can see there's a section called configuration. You can find everything you need there. Okay, so that covers the basic installation of our software. You can also add on additional options. One of them I talked about earlier is this remote option. That's one of them. Other options are you can add multiple users, which I alluded to briefly. By default, you get a single user mode because that's easiest for people that are running on a single computer. Once you move to multiple users, that unlocks more options in the software. And then you can also add on a slim cluster, which I imagine people that want to work with large data sets will want to have. And I'll talk a little bit about that in the next few slides. The overall procedure for enabling these extra options are making a few changes to your configuration file and perhaps running a few installation scripts. And then a lot of the other things might need to be configured in other systems, particularly in the Slurm cluster. There's a lot of setup that you need to do in the Slurm system to make that happen. Okay, so each one of these, let's talk about the remote access. This is when you want basically people to be able to access your server that don't have physical access to the hardware. There might be another computer on the local network. This can work over the internet too, but you have to be careful with security. So we have tools to enable encrypted connections and so forth. That uses a technology called a reverse proxy server. That's a separate service that you set up on your web server to basically encrypt your web traffic. This option requires that you have a domain name because that's how web encryption works. Special kinds of logins are possible by changing this reverse proxy option. So you can work with your organization's IT department if you want to enable single sign-on to your application by customizing your reverse proxy. Okay, so the way you find this in the documentation is that first installation document that I showed you. If you scroll down a little bit, there's a section called Next Steps. And here are the three options that we're kind of going over. And the first one is this Enable Remote Access. If you click on that link, it'll take you to a whole other document which explains how to enable the remote access options. Okay, next up is multi-user mode. By default, when you set up the software, it's designed for one user. So, and we're assuming that this user has physical access to the machine. So there's no other security because we're expecting at this point that the physical security is the security that you have. When you enable multi-user mode, a lot of that changes. So now users will log in with a username and a password. Because storing passwords is very difficult. We try to use state-of-the-art techniques to store passwords safely and securely. So hopefully you can trust that your passwords will be stored safely in our software. And one thing to keep in mind when going to multi-user mode is that in our software, the accounts that you create in the website are different from the user accounts that you might encounter in your cluster or your larger computing environment, your Linux systems. They're different accounts. So the user account that you have in the software isn't the same as a Linux account. And so when the software does data processing and it writes new files to the file systems, they will show up as the user account that the process is running under and not the user account that you typed into the login form. There are ways around this, but they require lots of fancy configuration. Don't have time to go into that in too much detail today. But if you want a situation where the website is creating files under a certain user, there are ways to do that as well. And again, to find this documentation, you go to this next step area and you click on the Enable Multiple Users link, and it will take you to a document where you can learn how to set that up on your instance. Okay, next up is configuring the additional Slurm cluster. As we talked about before, adding lots of compute power allows you to process larger data sets. One of the cool things about our software is that it's very flexible in how you set each job to the data processing system. So we have in our options, and you might see some of this later on in other sessions, you can customize the parameters for each job that's submitted to Slurm. And maybe you need to do that for reasons of your organization, or maybe you want to do it because of you want to request specific resources for a job or for other performance issues. We allow you to do that within our software. We want to do more work in this area, specifically to meet the needs of organizations that have lots of requirements about Slurm parameters. And so that's something that we're planning on in future releases. But the way you set this up, and again, I can't go into a lot of detail for time. In the next step section of the installation document, there's an attached Slurm cluster link. When you click on that, it will show the document that explains how to set that up, and then specifically the prerequisites and how to configure your Slurm system to work with our software and vice versa. Okay, next up is once you have a running installation, how do you upgrade it? How do you get new versions? And again, we try to make this as simple as possible. And if you go to, again, to the installation document, you go all the way to the bottom. There's a section called Upgrading to a New Version and explains in detail how to do that. The short version is you basically stop the services that are running, you just run the install script, and then you restart the services, and then you have the new version. Hopefully that's easy enough that anyone can do it. Okay, so that's it for installation and configuration. I'm going to talk now a little bit about managing the instance once you have it running. And our software comes with user interfaces to help you do that. I'll talk about those user interfaces in the first part of this, about management. How do you create users? How do you create groups? How do you learn about the performance of your system? And then in a second section here, I'll talk about when things go wrong, how do you find information about errors? How are errors reported to you? And where to find detailed information for detailed troubleshooting. Okay, our administration interface. If you noticed, all of our screenshots of our software have this big bar at the top, which shows the name of our software. You always see the version number up here, so you know what version you're running. There's a section with your name on it, or maybe it just says administrator if you don't have users. If you click on that, it'll take you to a page that looks like this. You can click on an administration link, and that'll take you to a page that looks like this. And in the administration interface, there are tabs that cover different tasks that you might want to do as an administrator. So look at the first one. This is just users. And again, this tab actually only appears when you have multi-user mode enabled. But what this does, it allows you to create your users. In my test instance here, my name is Jeff. I have the administrator permission. There are other users in my system. There's a demo that I set up. There's a demo account. There's a tester account that I use for testing, sharing things between users. You can create users. They have IDs. They have names, so they have friendly names. They're not shown in this little display here, but when you click on these buttons to interact with them, you can get more detail and set more options. Each user has permissions. And then each user has a group that they can be assigned to. And this is related to a sessions feature where you can control which people can access which data that were collected in our data collection sessions. So here's the groups. Here's what that looks like. This part is very simple. It's just you create a group. It has a name, and then you have a list of groups. And then you can assign users to that group. And then when you collect sessions, you can assign sessions to a group. And then each user that's in that group can see all the sessions that are in that group. And that's managed here in this part of the administration interface. This next tab is a little exciting because it's a diagnostic tool. It's called the PYP tab. And there's a big blue button here that says PYP WebRPC ping. That's sort of technical, but what it means is it's going to test parts of the communication networks in our system. For the local standalone deployment, what that's going to look like is next, when you hit this button, next it's going to launch a PYP process. It's going to do some trivial task, not any actual data processing, but just a small. If you hear that, that's my cat. Sorry. PYP is going to do some trivial data processing tasks, nothing at all really, and then send results back to the website. And if that works correctly, this tool will tell you that worked correctly. If it doesn't, it will give you some information for troubleshooting, maybe what went wrong. And the local deployment, that usually works pretty well. Things get a little more exciting when you look at the cluster deployment, and this loop gets a lot bigger, and there are more steps that could fail. And this is a tool to help you diagnose problems that happen along this path. For instance, SSHing into the login node, maybe the Slurm submission commands. The biggest point of failure is usually PYP getting access through the network to talk to the web server. Sometimes that can be tricky, and this tool will help you figure out whether that's working or not. We end up using it all the time. It turns out to be really useful. The next tab is the Jobs tab. What this shows an administrator is just a list of all the jobs that are currently running, information about their status, their progress, internal identifiers, mostly useful for development purposes. But this is just sort of an overview of everything that's running at the moment that you hit this refresh button. And it can just be useful for seeing when things are stuck, seeing if things are running for a really long time, and just generally troubleshooting and diagnosing issues. There's a whole lot of information here. I don't have time to go into it into too much detail. But it basically shows every time someone hit a run button, there's information about when the run button was clicked. There's information about what jobs are within that run button, and then actual jobs in the cluster system. And most of the times this will be Slurm, so you'll have information about the Slurm ID. That might help you, for instance, if you want to use the Slurm command line tools to look for information about jobs, you can find those associations in this tab. The next tab is the Performance tab. This is helpful for determining if your web server is keeping up with the load or not. This only affects the web server itself, so if you're running in a clustered environment, it won't give you performance information about Slurm nodes. So just briefly, the kind of information that this gives you is this operating system level information. So it can tell you about total memory usage in the entire operating system, how many CPUs, how much work they're doing. File descriptors is probably not something that people are going to need too often, but when it does become a problem, you'll be happy that this is here. The next section here talks about the memory of the web server process itself. A web server is built based on Java technology, so it runs in the Java virtual machine. And the Java virtual machine has a lot of information about memory usage that can be useful for diagnosing performance issues. Sometimes when the website gets slow, the issue might be because it ran out of memory. The statistics here will tell you that. The last section here is just information about general performance of requests to the web server. So in this particular snapshot that I took here, in the last 30 seconds, there were 88 requests. So that's roughly 3 requests per second. And this here is a breakdown of, it's a histogram of the latencies for different requests. So if you look at this, the top 5% of requests finished within 1 millisecond, the top 90% of requests finished within 5 milliseconds. And so on. The worst request took 265 milliseconds. Generally, these numbers are pretty good, but sometimes when things are running slowly, you might see this higher percentile request take, times within the seconds or maybe tens of seconds. And in that case, there may be an indicator that your web server isn't able to keep up with the workload that you're giving it. So that performance tab will help you figure out maybe you need to add more memory to your web server. Okay, on to troubleshooting. So hopefully you won't run into any errors at all. But when you do, the first way you may be notified of that is in the interface, you might see a little red pop-up here. Usually it'll have some information about what you can do immediately to work around the error. In this case, I didn't type in a value into a text field, so I got an error that says, please type a value into the text field. You can see lots of things in these red boxes. They might not be as simple as something you typed into a text field. It might be as complicated as, we submitted a job to the cluster, and then something happened, and then the error bubbled all the way back to the interface, and you got a message here saying, something went wrong. You might need to do something to fix it. So the first place to look about errors and troubleshooting is on-screen information. If you need to get more detailed views, we have detailed logging of errors and log files. One of these areas is in the console for the actual web process itself, and depending on how you install it, there are different ways of accessing that. This troubleshooting section of our documentation will tell you how to find that information. If you look in the menu here, it's under the installation troubleshooting section. That'll end you up on this page here. And if you look through this page, there's lots of information about where to find information about errors. One really important thing to note is if you see a little red box pop up in the corner of your screen that says internal error, what that means is an error happened, but we can't share that information with the browser, maybe for security reasons, but an administrator can look at the log files and get all the details about that error. And so if you see internal error in your pop-ups, what that means is there's one of these logs, it's called the micromount log. It's going to have more detail about the error in there. And you can see here, this is a screenshot of our documentation about troubleshooting. There are lots of different log files that log different things for various reasons. It'd be nice to have everything in one log, but for technical reasons, we can't do that. So at different stages of the startup process, we have access to different ways of logging. And so the first 4 logs you see here are probably not super interesting because hopefully those things usually just work. Most of the errors you're going to find are going to be in this micromount log, and those are errors in our application itself. An example of something you might see in this log that will be helpful for troubleshooting is this is what an error message might look like. These log files are text files, they're very dense, but you might see sections that look like this. But this top portion is an error message. And so here's an error that I generated for purposes of this presentation. An authentication error where a user tried to log in, they weren't allowed because they didn't have permission. And you can see there are details about this denied access attempt that are maybe sensitive. So that's why we don't share this information with the browser right away. So the user that tried to log in was me. I have these permissions, I have these groups. I tried to access this file path and it said, no, you can't do that. That information can be found in the logs. It can be helpful for troubleshooting. Sometimes though, there's just a bug in our code and our code didn't do what it was supposed to do. And so there may also be information about the code in here that helps us as developers figure out where the problem in our code is. And sometimes when you run into problems, it can be helpful to send that information to us. And I'll talk about submitting error reports later on. But you'll find that kind of information in this log. There's also a timestamp to tell you when that thing happens. Sometimes reading these log files, it's hard to get a sense of the timescales things are happening on. So these timestamps are basically the only thing you have. Okay, next, I'm going to talk about briefly our Python API. This is something brand new. We just started working on it. And this is primarily aimed at developers of other applications that want to integrate with nextPYP. What this allows you to do is if you have an app and it's written in Python, you can access functions of the nextPYP website from your app. Reasons you might want to do this include perhaps integrating nextPYP into your own data processing system, or maybe you want to get feedback from nextPYP's data processing to inform or influence tasks within your system, sort of responding to things that happen within nextPYP. There are ways to do that with real-time systems in the in the Python API as well. So on the right here, I have an example of just a very simple task that we do with this API. First thing you do is create a client by instantiating this client object. I'm not going to go too much into programming details for people in the audience that aren't programmers, but I want to point out a few features. All you need for this to work is the URL of your web server. And you will need remote access for this. So a domain name is probably a requirement here. And then I want to talk a little bit about the security model here, because there's this big section called credentials, and there's, you have a user ID, you say I want to access functions that may have this user, and there's this thing called a token. I want to talk a little bit about these app tokens, because it might be slightly different than other things you've seen. So when we handle login credentials in our Python API, we don't ask the app to store user passwords. It turns out that could be a very risky thing to do, because handling passwords safely is just a generally difficult task. And the penalties for getting it wrong can be quite severe, because people often reuse passwords between many different websites. So if one website doesn't store a password safely and that password is stolen by an attacker, that might give the attacker access to many other websites too. So we don't ask that apps that use the Python API have to deal with this problem at all, because we have these app tokens instead. So you can think of an app token as a kind of a password, but it's less risky to deal with because it's very limited in scope. And if you do manage to steal it, all you get access to is a few minor things, and you don't get access to other websites. So in this code sample we have here, so say we've created, let's say we've created our client, we have appropriate access. We can just call a function here. Again, I don't want to get too much into the details of the programming language, but you can access lots of different functions of the website. One of them is called single particle sessions, and you can call list. And what that does is just return a list of all the single particle sessions. And then once you have those, you can print out various information or do whatever you want with them. So these app tokens are a little bit different than user passwords, because the way this process works is your app can request fine-grained permissions to nextPYP functions on behalf of the user. And what that looks like is here, some screenshots. So back in your sort of personal page here, you can click on the apps link, and I'll take you to a page that looks like this. And in my testing system, here's an app that I've created. The app is called Tester. It is asked for certain permissions from my user on the nextPYP website. One of them is list projects. One of them is listen to projects. This is for real-time functions. And that's it. That's all the app token can do. So this app token represents a grant of a few fine-grained permissions. And that allows apps to safely access nextPYP without having a lot of risk and security issues. And then the cool thing is the users can remote access at any time. If for some reason an app is misbehaving, the user can just cut the cord, and that's it. Okay. Getting help. This is the last section. Our software is open source. If you're so inclined, you can go and read all the code. It's on our GitHub. It's just github/nextPYP. And here's what that looks like in your browser. If you click on this little repositories button, you'll see all the areas in which our code is organized. So there's the PYP code, there's the next code, there's a whole bunch of stuff down in here, but the top two are probably the most visible. And as Alberto mentioned before, we have a very permissive license. So you not only can you read the code, you can compile it, run it, do whatever you want with it. We like to share. Okay, but the other part of this GitHub section is the discussion section. And this is where probably the primary people so far that people have been asking for help with the software. And we found it's really useful because we're getting a lot of feedback from people that are using the software, and there's a lot of information in there about how we can make improvements. But also people are just having problems with the software, and we're able to help them using the system. And so the way this works is you click on the discussions tab, and you're going to see a page that looks like this. There's a few announcements at the top, hey, the workshop, that's pretty cool. This big green button will open a new discussion if you want to ask a question or if you have an issue you want to share with us. You can search for previous issues, and then you can sort of see the recent ones down here. Sometimes the problem that you're having, someone else may have already had that problem. Maybe they've already gone through this process with us and they have an answer, and you can just look at that answer, maybe get the help that you need right away. If not, feel free to open a new discussion, and we'll be happy to help you through any issues you're having. Yeah, I got ahead of myself on the slides. Okay, some helpful information for when you do want to report an issue is it's really useful to us as developers to give us certain information about the problem that you're having. For instance, what did you want to happen? And what happened instead? Sometimes messages that are describing errors just say it broke, and sometimes that's not very helpful to us because we don't know what broke or what was supposed to happen. And so just giving us more detail and more information is going to make us better able to help you. Some other things that you can add that will help is information about the software you're using, which version are you using? Different people might be using different versions. Maybe they don't update right away. That's fine. But knowing that will help us get an answer that is more useful to you. Are there any relevant error messages? So if you saw a red pop-up on the screen, having that information would be helpful. If there are any error messages in the log files that I had mentioned, having that information is helpful too. Another big issue is sometimes issues happen every time or only sometimes. And even just knowing if it's one of those two things can help us figure out what's going on, because those two issues usually have different causes. Things that happen every time have a certain pattern to them, we can look for that. Things that happen only once in a while have another pattern, we can look for that in different ways. And then a really, really important thing is if you're having an issue, can you cause the issue to happen in a reliable way? And then if those steps, you can write this down and share this with us, we can cause that issue to happen in a reliable way in our testing environment. And that's the easiest way to figure out what's causing issues, and that helps us fix them. Okay, so to summarize, I've talked about our software, different deployment options, different hardware requirements, what kind of data processing performance you can expect out of that. I talked about the user interfaces, administration, and on the user side, talked about how to install and configure the software and various options for enabling additional features. I talked about how to manage your instance, dealing with users and groups, and looking at the performance of your web server, and diagnosing maybe some network issues with that PYP ping tool, which is really useful. I talked a little bit about our upcoming Python API. It was written on the slide, but I didn't mention it before. We are actually working with the NIEHS and the SmartScope developers to sort of do the first integration between another app and nextPYP. And then I talked at the end briefly about how to get help from us. We're happy to help you. Just send us a message. Thank you all for your attention. I'll be happy to take any questions now.
All right, thanks, Jeff. So we have a couple questions for you. The first one is someone is wondering if you can run jobs from two different projects at the same time.
I believe you can. The running queue is per, okay. Did you say per jobs or per projects?
Per projects. How many if you can run two projects at the same time? Yeah.
Yeah. So within one project, each job runs sequentially, like I said. But if you have two different projects, they can run in parallel.
Nice. All right, and then we have another question from Asa, and is there a way to currently run jobs in an HPC setup as a user other than the user that is running the central process for nextPYP? I think you addressed this a little bit in your slides after they had typed the question, but just to...
Currently, this isn't possible in our software. There are ways to do it at an operating system level, but they're a little bit tricky to get right. And we've looked briefly into doing this. It would require a bit of investment on our part, but it's not something we're opposed to, and we may do more work on that in the future.
Nice. All right. And then another question was, and then again, you hinted at this in your summary slide, but will we start to incorporate bisect or another high throughput data acquisition methods into the web interface?
I don't know the answer to that one, but maybe someone else does. Can anyone else chime in?
Maybe I can say, obviously I think it's obvious that, the data processing needs to be talking or happening very closely with the data collection. So I think that's the direction that a lot of the development, not just for nextPYP, but other tools is gonna, evolve into. So I think you definitely want to be able to get feedback from data pre-processing, data analysis during data collection, so you can adjust and go back and start making the most out of your microscope session.
All right. Nice. And then another question we have is, what if we don't have a HPC available? Have we considered hosting nextPYP in like AWS or something so that we could use it there?
We have looked into that. We
Nice.
haven't had a lot of time to work on that yet, but it's something that we've looked at in the past, and it's something we're interested in doing. The difficulty with doing that is the cloud services are very expensive, and so when we design a system like this that has huge compute requirements and huge data requirements, we have to make sure that we're being efficient with cloud resources and we're not racking up a huge bill and doing very little work. So designing a feature like that is something that we're interested in, but it's tricky to get right, and we're going to take our time.
Makes sense. And then another question is, can nextPYP be run from a Conda environment?
A Conda environment is a Python environment, right? So
Yeah.
our web server is just a regular operating system process, so it wouldn't need Conda. But the PYP software itself is mostly in Python, and I believe that interacts with Conda. And maybe Alberto can chime in with more details here. I'm not really sure.
Yeah, so I guess we didn't talk about the containerization and everything like that, but the way I guess this is probably referring to the command line interface in nextPYP, and that should be it's not set up to run in a Conda environment because it's kind of it runs out of this obtainer technology, which essentially has all the dependencies inside. So then you just you execute it directly. You don't need to worry about making sure they have the dependencies and so forth. If you did wanted to go interact, I guess, directly at the at the Python language level, there would be ways of having like like a package that you can install within Conda, but that's not the way it's set up right now.
That being said, though, our Python API would be able to be used within a Conda environment because it's just a client talking to a server that's set up elsewhere. So maybe that could be an option for people that want to integrate nextPYP into their own data processing systems.
Yep. All right, and I think we have time for one more question. And I guess that's we'll do a short one. So roughly how often do we update PYP was the question. How often are upgrades available?
I think so far we've been putting out new releases with feature additions and bug fixes every few weeks. I think it's been our cadence so far. I think we intend to keep up with that as much as we can. So I expect to see new features and things delivered hopefully fairly quickly.
Nice. All right. Well, thanks, Jeff. And then we have a 10-minute break before we start session 2.
All right, thank you.